So, what if an AI could just invent entirely new world champion AI algorithms all by itself? I mean, algorithms that are just flat out better than anything a human has ever designed. Well, let's dive into this because believe it or not, this isn't science fiction anymore. And this isn't coming from just anywhere. This breakthrough is straight out of the labs at Google DeepMind. You know, the same people who brought us game-changing systems like AlphaGo. They've cooked up a new approach that could seriously change the way we create AI from the ground up. Which, brings us to the big question. How do you even build an AI that can compete at the absolute highest levels? Think about complex games like poker or liar's dice. For the longest time, the answer has always been, well, with a whole lot of difficulty. And that difficulty, really, it all comes down to one core problem, what researchers call the human bottleneck. For decades, just how good an AI could get has been capped by the creativity and, honestly, the gut feelings of its human designers. Think about it like this. Building one of these elite AI algorithms has always been this incredibly painstaking manual process. You've got brilliant researchers relying on their intuition, on mathematical hunches, and just endless trial and error to make these tiny, incremental improvements. It's slow, it's super expensive, and it's been holding the entire field back. Okay, before we go any further, there's one key term you absolutely have to understand: exploitability. It's really just a score for how easy an AI is to beat. The higher the number, the more flaws it has. The lower the number, the closer it is to a perfect, unbeatable strategy. So just burn this into your brain for the next few minutes. On all the charts we're about to see, lower is better. So to smash through that human bottleneck, the team at DeepMind's built something totally new. An AI that doesn't just play games. It's an AI that writes the code for other AIs. Everybody, meet AlphaEvolve. So what is AlphaEvolve? It's a system that uses a large language model, like Gemini, to automatically discover brand new, and as we'll see, way better algorithms for playing these complex games. It's not just automating the work, it's automating the act of invention itself. And this comparison just lays it all out perfectly. On the left, you've got the old way, slow, limited by what we humans already know. But on the right, you have AlphaEvolve. It's an automated discovery engine that literally evolves the source code, which lets it uncover completely new ideas that a person might never, ever think of. So how in the world does an AI evolve computer code? Well, the whole process is really fascinating, and it cleverly borrows from a concept we all learned about in biology class: natural selection. It all works in this constant loop. First, it picks a pretty good parent algorithm from a whole population of them. Then, it uses the large language model to mutate it, basically to rewrite parts of the code and create a new child algorithm. That new child is then thrown into the ring and tested in a bunch of games. If it performs really well, if it has a low exploitability score, it survives and gets to join the population, ready to become a parent for the next generation. It's survival of the fittest, but for code. The researchers call this semantic evolution, and that word, semantic, is key. Unlike older methods that would just kind of randomly swap bits of code around, the LLM makes intelligent, meaningful changes. It's not just changing the syntax, it's changing the ideas in the code. Okay, so the theory sounds incredible, right? But did it actually work? The answer is a massive, resounding yes. AlphaEvolve didn't just find some little tweaks. It discovered 2 completely new champion-level algorithms. Its first mission was to take on a classic family of algorithms called counterfactual regret minimization, or CFR for short. This is pretty much the foundational method for teaching AIs how to play games with hidden information, like poker. The goal was pretty simple: evolve a better version. All right, now this is where things get really, really wild. So on these charts, we're looking at that exploitability score we talked about. And remember, the lower the line goes, the better the AI. Now, all those colored lines are different human-designed state-of-the-art methods. But just focus on the brown line. That's VAD-CFR, the one AlphaEvolve discovered. In game after game, you see it just plummet. It completely separates from the pack and achieves a performance level that is just orders of magnitude better than every single human competitor. This isn't just a small step forward. This is an absolute blowout. So what was its secret? Well, AlphaEvolve came up with some truly weird and, frankly, non-intuitive strategies. It learned to dynamically adapt based on how chaotic or volatile the game state was. It figured out how to asymmetrically boost certain updates to be more aggressive, and maybe the most bizarre move of all, it created something called a hard warm start, where it literally just learns for 500 rounds before it even starts to build its final strategy. Who would think of that? But okay, was that just a one-hit wonder? To really prove this thing was legit, the researchers pointed AlphaEvolve at a totally different class of algorithms called Policy Space Response Oracles, or PSRO. And incredibly, you're not going to believe it, the result was exactly the same. They wanted to see if this was a fluke, and nope, again, just follow that brown line. That's the new AI-discovered algorithm, SHOR-PSRO. And across a whole new set of games, you see the exact same story. It consistently learns faster and reaches a lower, better level of exploitability than all the established human-made methods. We're seeing a really clear and undeniable pattern here. And once again, its secret moves were totally novel. It invented a hybrid solver that blended two different approaches together. It developed this dynamic schedule that automatically shifted the AI from exploring new ideas to exploiting the best ones it already found. These are complex, elegant solutions that AlphaEvolve came up with all on its own. And of course, here's the ultimate test for any new discovery. Does it actually generalize? I mean, are these algorithms just good on the games they were trained on? Well, this slide shows a ton of data, but the key takeaway is super simple. When they presented these AI-born algorithms with new games they had never seen before, they continued to dominate. This is the proof that these discoveries are robust and fundamental, not just some clever trick for one specific setup. So, this all brings us to the bigger picture. Because what this means is way more important than just making better poker-playing AIs. This could be about a fundamentally new way of doing science. Look, the most important thing to get here is that AlphaEvolve wasn't just tweaking a few numbers. It was writing code. It was discovering entirely new mechanisms. That weird warm start, the hybrid blending, things that were, in the paper's own words, completely non-intuitive to its human creators. And this quote from their conclusion just sums it all up perfectly. Automated search can find strategies that are not only super effective, but that we humans might not have even thought to look for. It's actually expanding the boundaries of our own creativity. And that is why this all matters so much. It signals a potential shift, a really profound one. We could be moving from an era where humans design all the tools to an era where AIs help us discover new tools. And that could accelerate the pace of scientific progress itself, not just in AI, but in any field that relies on complex algorithms. Which leaves us with this one final, pretty mind-blowing question. For decades, we've used AI to solve problems that we give it. But now, it seems like AI is starting to discover the very methods of discovery. So if it can do that for game theory, what's it going to discover next?